Okay, so we've got the integral of the natural log function, and I'm telling you, use integration by parts for this. So this is not one of those ones that has like a product of two functions sitting in the integrand, and it's clear that integration by parts is the way to go. This is one that's a lot like integrating the inverse tangent function, for example, where you just want to let u be equal to that function that's in there because du is going to be some simple algebraic thing. The derivative of the natural log is 1 over x. So I'm going to say u is natural log x, which means du is 1 over x dx. So the benefit there is that we've gone from this transcendental function to a simple algebraic function, and we're a lot more likely to be able to handle whatever comes out of this. dv is just the leftover piece, just dx. And so v is going to be equal to x. And so my integral becomes uv x natural log x minus the integral, oops, it's a definite integral, so I've got to evaluate that, minus the definite integral of v du. So that's x times 1 over x dx. And those x's are going to cancel, leaving me with just a 1 in the integrand. So if I were to look at this in its indefinite integral form, so forget about the limits of integration right now. Well, maybe I'll write one more step first. But I'm going to leave this unevaluated because I want to make a point. When I integrate 1 dx, I just get x. All right, so if I looked at the indefinite integral form of this, what I found out is that the integral of natural log of x dx is equal to x natural log x minus x, which is actually an important formula to remember. Or if you want, you could just remember, oh, I'm going to do integration by parts when I see this, and I'll figure it out if I forget the formula. Just to verify real quick. Product rule on this first thing. Derivative of the first gives me 1, and natural log is the survivor. And then I have another term where I leave x alone and differentiate the natural log. And then I have minus the derivative of x. Well, here's a 1 minus 1, so those guys are gone, and I get what I started with. Anyway, this is one of those formulas that's important enough where you probably should have it memorized. So let's get back to actually analyzing this thing, evaluating across the limits. When I plug in the lower limit 1, the natural log of 1 is 0. So that's nice. I don't have to worry about that. And I end up with an e. Natural log of e, but natural log of e is just 1. And then on this second term, I plug in the upper limit, plug in the lower limit, and I have a minus negative 1. So this turns out really clean. I have e minus e plus 1. Turns out that area is exactly 1. Maybe we should verify with maxima real quick, because that's instructive on special symbols and all that. So I'm going to integrate natural log. In maxima, that's just log. As x goes from 1 to percent e, that's the special symbol for that number e. And I get 1 out of it. So that's comforting.